Hello everyone, myself Ashwani Jaiswal, a PhD research scholar at IIT Madras, and my presentation topic is optimizing structure from motion parameters for volume estimation of construction and demolition waste. Moving on to the outline of the presentation, we'll be starting with the introduction, methodology, experimental design, results and discussion, and at the end we'll be discussing about the conclusion and the recommendation. By 2030, urban population is expected to reach more than 60% of the total population as per the United Nations reports, which is the reason for the major development in the metropolitan regions and leading to the activities such as construction, demolition and renovation. These activities leads to the generation of C&D waste, which we call as CDW. If we talk globally, we are generating about 10 billion tons of waste each year, which is contributing to the reverse supply chain. And as we can see here, reverse supply chain starts from the collection of this waste, and these waste get transported to the recycling facility, and we eventually get the recycled product at the end of the reverse supply chain. However, the efficacy and the efficiency of this reverse supply chain relies heavily on the localized C&D waste quantification, as it contributes to the waste collection and transportation optimization, which is currently not optimized as we don't know how much quantity of waste is present around the cities. Thus, there is a need for the quantity estimation of the C&D waste to improve the reverse supply chain. Moving on to the quantification part, in order to quantify, 3D point cloud serves as the technology to achieve the volume estimation accurately. For that, various studies have suggested that the use of UAVs, terrestrial laser scanner and SLAM. However, they all come with their own challenges such as regulatory constraints, extended time requirements, and scalability and cost issues. Thus, there is a need for an affordable and portable device. The affordable and portable devices such as stereo cameras, LiDAR equipped devices have already been discussed in the literature, but smartphone devices have not been covered in the literature as such for the volume estimation. Structure from motion is a computer vision technique through which we can generate 3D point cloud and a high precision 3D point cloud from the images captured from any device or any monocular camera, so that we can use the smartphone devices to actually convert 2D images to 3D point cloud. In literature, there are different parameters, like the methodological parameter have been addressed in the literature. However, parameters such as environmental and capture parameters have rarely been discussed in the literature, and they lack in terms of their specificity, and they fails to consider the environmental and capture parameter. And this is the same in terms of the localized C&D waste, and thus there is a need for the investigation of environmental and capture parameter influence on the SfM-based point cloud volume accuracy compared to the LiDAR point cloud. Thus, the methodology starts with the data acquisition of the construction and demolition waste stockpile, and we have taken a 360-degree orbit video around it utilizing a smartphone camera. We have also placed the CC tag, which serves as a ground control point. Once the video sequences were captured, we extracted the frames using a Python script, and the structure from motion point clouds was generated utilizing a Mushroom software. The last step is the post-processing, where we remove the bases and the outliers to eventually get the volume of the C&D waste. This was the primary data. Along with it, we also captured the secondary data utilizing a LiDAR point cloud using the iPhone, and where we also did the removal of base and outliers, where we kept the post-processing same for both the process and both the data to eventually compare and evaluate them. Now, from the video sequences, we actually extracted the images utilizing the Python script and named it as pre-processing, and later on these images were fed to the Alice Vision Mushroom for the processing of the point cloud. These are the nodes that we have utilized in the Mushroom, starting from camera intrinsic property, feature extraction, image matching and feature matching, and eventually we observed and got the structure from motion point cloud at the end. But in this, we observed that the point cloud we obtained utilizing the iPhone cameras, it was aligned in the YZ plane rather than the XY plane. So we then performed the scene alignment on it and added a node 6 to it so that we can align it on the XY plane. Eventually, we performed the scaling with CC tags and rescaled the point cloud utilizing the ground control point that we have already set up. So eventually, at the end of we got a rescaled point cloud as an output to serve as a precise volume estimation. Now moving on to the post-processing part. Once the point cloud was extracted, we performed base and outlier removal utilizing a hybrid segmentation techniques of the ransack and DB scan. And once the points were removed, we eventually extracted the CND waste stockpile to calculate the volume of it. We have also set up some of the experimental design to check the influence of environmental and capture parameters such as height and distance, shadow and lighting, frame extraction rate, and frame resolution. So multiple levels of these factors was considered, such as in terms of height and distance, we have captured the multiple height and distance from the stockpile. In terms of shadow and lighting condition, we have tested the sample in 0 lux, near to 0 lux, and 1000 lux. And in terms of frame extraction rate, 1 fps, 2 fps, all the levels were decided. And in terms of frame resolution rate, like 4K to full HD, and low resolution also we have tested. And these were tested for 3 CND waste stockpiles. Moving on to the results and discussion that we got from initial 3 CND waste stockpiles, we got the optimal value of 1.5 times height of the stockpile as the camera height and distance. And in terms of the lighting and shadow, we got that no shadow gives a better result. However, there was no difference in terms of the accuracy, just the difference was observed in terms of the points generated per time. In terms of the frame extraction rate, we got 1 frames per second as the optimal value, and for the frame resolution we got 720p as the optimal value. Utilizing all these optimal values, we have constructed 30 different CND waste stockpiles having varied shapes and sizes, and we have captured both the structure from motion point cloud and LiDAR point cloud. Eventually, when we plotted them, we got an R-square value of about 929, having a LiDAR based point cloud volume compared with the SfM based point cloud. And in terms of the processing time from end to end, from the extraction of the video till the volume estimation, we observe that SfM is 3.8 times faster than the normal LiDAR based solution and the pipeline. Here you can see the SfM achieved the volume estimation in just 97 seconds. However, LiDAR took about 373 seconds. So thus, in terms of the conclusion and future direction, environmental parameters has insignificant impact that we have observed. Also, in terms of capture parameter, we observe that these are the primary determinants for the SfM performance. And also field variability were not assessed for this particular study. Thus, it is recommended to utilize the site layout, terrain complexity, material composition, and climatic conditions affect also into it. And this study was relied majorly on the iPhone camera sensors and iPhone LiDAR sensor. So a future study should also consider the alternative smartphone devices. These are the references that have been utilized in the study. Thank you so much for listening to the presentation. If you have any query, you can reach out to us into our email IDs. Thank you so much.